everyone. We come to the experiment number 9A, which transmits data through the serial port using RS-232 protocol. I hope you've already gone through the manual so that you can grasp the concepts faster as we go through the presentation, the execution of the program on Keil, and also the simulation on Proteus. There are a few things we have to know before writing the program for serial transmission. They are UART, RS-232, serial port, MAX232, baud rate, SCON, and SBUF. We've already dealt with some of the topics in the list in previous experiments. Nevertheless, we shall quickly recall them and see how to write a program for serial data transmission. UART is the abbreviation for Universal Asynchronous Receiver Transmitter and is a commonly used hardware module for serial communication based on communication protocols like RS-232. Serial communication uses only one or two data lines to transfer data and is generally used for long-distance communication, and the data is sent one bit at a time. IBM introduced the DB9 RS-232 version of Serial I/O standard, which is most widely used in PCs and several devices. The hardware, which is highlighted by a red box, is the D-shell connector with 9 pins, which is used for serial data transmission using RS-232 standard. A serial port, like other PC ports, is a physical interface to establish data transfer between computer and external hardware or device. This transfer through serial port takes place bit by bit. The serial port pins of the 8051 microcontroller are pin number 10 or port 3 bit 0 or P3.0, which is used for serial reception, and pin number 11 or port 3 bit 1 or P3.1, which is used for serial transmission. Pin number 10 is also called the RxD, and pin number 11 is also called the TxD. AT51 uses the TTL standards of voltages, which is 0 volts for bit 0 and 5 volts for bit 1, while RS-232 standard ranges from plus 25 volts to plus 3 volts for bit 0 and minus 3 volts to minus 25 volts for bit 1. Due to this reason, RS-232 voltage levels are not compatible with TTL logic. To make the RS-232 compatible with the microcontroller system, a voltage converter is required. This converter is the IC MAX232, also known as a line driver. An important parameter considered while interfacing serial port is the baud rate, which is the speed at which the data is transmitted serially. Refer to experiment 7A for more detailed explanation on baud rate. SCON register is used to set the mode of serial communication. Here we use mode 1, in which the data length is of 8 bits and there is a start and a stop bit. The SBUF register is an 8-bit register used solely for serial communication in 8051. For a byte of data to be transferred via TXT line, it must be placed in SBUF register. Similarly, SBUF register holds the input data received serially by TXT line of 8051. The algorithm consists of 7 steps, which will help to write a program in embedded C. Let's go through the steps one by one. Step 1. After 8 bits have been transmitted, it is indicated by making Ti is equal to 1. So initially it has to be reset so that the transmission can be monitored. Therefore, Ti is made 0. Step 2. Set the SCON register bits for serial communication mode, that is 50H or 01010000. Step 3. Set tmod register for timer 1 mode 2 operation, that is 00100000 or 20H. Step 4. Set baud rate to 9600 by loading TH1 with FD in hexadecimal or -3 in decimal value. Step 5. When the timer is started, the transmission begins. Step 6. SBUF receives the character to be transmitted. Step 7. We use the while loop to transmit the set of characters in an infinite loop till the program is manually stopped from running. Let's go over to Keil, where I'll explain the embedded C program to transmit a set of characters. We have the program here. Include reg51h is a header file which enables us to address the hardware registers. Okay? Now today you write a program for 8051 and you can address the registers without memorizing the numerical address of the register. So you can just address them through names. So this will take care of that. So if you just call them by their names, it will understand. And today if you write it in 8051 and tomorrow you want to run the same program on a different microcontroller, you just have to again include this header file. It will take care. So all the addresses of the registers will change if you run this program on a different microcontroller. The addresses will change. You don't have to know all the addresses. You just have to include this header file and it will take care of it. And you just address them by their names. The header file will know where to go. This void, this is a function, serial transmit function. So this is the function which you are going to declare here, and in main you're going to call it, and here this is what it does. Okay, here the details of the function are given here. Okay, so first declare the function unsigned character. These are the unsigned characters which you want to display, and this is a function which will display these unsigned characters. Start the main void main void. So it void main void means it returns nothing, and this is a main entry point to the main is the entry point to the program, C program, embedded C program. So as in the algorithm, I told you that we have initialized all these values. SCON is 50, tmod is 20. This is the baud rate, -3 th1 is the baud rate, -3 or 9 fd, and which sets it to 9600 baud rate, and then start the timer. And then you have the infinite loop. While one is the infinite loop, and here you're going to call the function serial transmit. You're going to send the variable, you're going to send the character h. So when you call this function, it comes here. It comes here, and that h is actually x. So h will now go and sit in SBUF. So the timer takes care of the speed of the transmission. So SBUF, h is now sitting in SBUF. After that transmission, Ti will become 1. It has been set to 0. Ti will become 1. So when it becomes 1, it means the transmission is over. Then come out of the loop and make Ti equal to 0 so that you can transmit the second character, that is E. So after that it gets out and it comes here to the second one. So E is, you call the function and send E. So E comes here, it goes and sits in fbuff, and when the transmission is finished, Ti becomes 1, get out, make Ti 0, go back. And then the same thing happens to L. Call the function with L, L comes here, L goes and sits in sbuff. After transmission, Ti becomes 1. So this goes on and on and on until it comes to the end here. 0D is the number which is given to start on a new line. So that is why you will have hello world, new line, hello world, new line, hello world. So it will repeatedly display hello world on a new line. Okay, so that is a very simple embedded C program to display, to send the characters hello world through the serial port and a display. This is transmission. This is a transmission part. So we'll just run it here. We'll also run it on Proteus and see. Okay, it is similar to transmission. So you open the window UART window and run the program. So you can see that it has transmitted hello world. So it is repeatedly transmitting hello world, but you cannot see it. That's all. Okay, we'll see that on the virtual terminal on Proteus. Okay, so we'll just stop this, stop debugging, and we'll go here. I already have this. We'll zoom into this portion. So I told you that pin number 10 is RxD and pin number 11 is TXD. We are going to transmit from 8051 to an external monitor, external device or PC. So you connect only 11. So TXD should be connected to RxD of the serial modem or RS232. Okay, and RxD should be connected to TXD. So that's a cross connection. Okay, now we'll open a virtual terminal. So I'll just run this program. These are the connections. And make sure that you have connected the hex file. You have opened the hex file, open it. Okay, simulate it. Okay, virtual terminal. Okay, virtual terminal. So here you have hello world which is being transmitted. Okay, so that is how this program works. And stop and exit. Before we go, let me give you a tidbit of interesting information. The RS-232 standard for serial communication transmission of data was first introduced in 1960 by the Electronic Industries Association, or the EIA, as a recommended standard. EIA also recommended the RS-279, which is a standard for electronic color code originally known as the RETMA color code, which we have learnt as B.B. Roy of Great Britain has very good wife. So now there's something which connects the RS-232 serial communication standard and the color code of resistors. With that, we come to the end of this program. Till next time, study well, stay home and stay safe. Bye-bye.